Hello, thank you everyone for joining today. It's our first one of 2020 for the AWS Louisville Users Group Meetup. I'm pretty excited to get that started. Virtual makes it certainly a lot easier on the meetup organizers. My name is James Strong. I'm the Cloud Native Director for Contino. They help support and sponsor this, aka they pay me to do this. And I also run the CNCF meetup in Louisville, and I'm the co-sponsor for the Golang meetup as well. We'll do a shameless plug because CJ is going to be speaking tomorrow virtually about migrating an application from Beanstalk to AWS's EKS. So relevant for this group since it is AWS EKS. So please feel free to join that group as well and join us tomorrow and heckle CJ. But today we're going to be heckling Fabian De Silver. He is a partner SA at AWS. I work with him a lot on events like this with clients, discussing other ways to get engagement from an AWS perspective. And we're gonna have a lot of fun today talking about alien attack and serverless. So with that, does anyone have any updates, wants to talk about their AWS projects that they're working on? Anything along that nature before we let Fabian give his introduction and get started? You guys have any ideas around what we can do in this meetup, whether virtually or when we can start doing this in public? Please let me know. Always need advice, discussions, all of those things. So with that, I will let Fabian take over and we'll go from there. Thanks, guys.
Cool. Thanks, James. Welcome, everyone. My name is Fabio da Silva, Partner SA. A Partner SA is a solutions architect that works at the AWS side supporting partners for engagements and helping them to design architecture, design solutions to build solutions on top of AWS. I've been with AWS for 4 years and 2 days. From half of it, I was supporting customers in Latin America, Brazil, Argentina, Chile, Colombia, Mexico, and so on. And since the second half of 2018, I'm here covering customers and working with partners in the US Northeast region. I'm based out of New York. Cool. So I'm going to let the game open, right? So if you can go and keep playing by the end if you want. So the idea today, I'm going to talk a little bit about near real-time data processing pipelines on AWS. We are going to have some quizzes during the discussion, and if you have any question, please post it to the chat, Zoom chat room group, because at the end we're going to go through these questions and talk a little bit more about your ideas and next steps with alien attack and how we can work more together with Contino and James to do more things in the field of serverless. Okay, let's go ahead. Let me open my presentation here. Cool, can you see my screen? The deck's being presented.
I can see your screen. Did you want to mention the poll that you had?
Yeah. We have this pool. Please join. I see that that James has posted the link on the chat group. Please answer this pool just for us to have an idea who we have here. And we are going to have other questions during the discussion, right? Just to have you participating more actively in the presentation. I'm going to go through a deck right now. We are going to have kind of 1 hour discussion with this deck. And let's go through all of it. And at the end, we're going to open some time for discussions. I can get back to certain slides, and I'm going to share the deck at the end with you, right? I'm going to send the deck to James so he can share with everyone on the AWS group. So let's go ahead. So this is the topic for today, right? Architecture patterns and choice for near real-time data processing pipelines on AWS. A big name for alien attack, right? That game that you guys have just played. So why we are starting the day, starting discussion with alien attack, right? What we can learn from, first thing, like super fun, but there's more there, right? If you think about the kind of application that has this kind of producer-consumer pattern, alien attack is one of these cases. And you are going to find the same pattern in a lot of different industries, in a lot of different kinds of applications. In fact, we can extrapolate to all applications. Every and all applications have users sending information on one side. On the other side, you have different users or different systems consuming information. Depending on the size of the payload that you are sending, the rate of ingestion, requirements for processing the incoming data, and the querying profile over the data. What more? Maybe on the required technology and integration, the requirements regarding technology and integration, we may need different configurations for the solution architecture. We might need different tools, different services, and maybe use different patterns, right? So if you think about a way that we could express the requirements for alien attack, if a customer asks you to build something like that, this is going to come with something like this, right? I need you a web application where I need to provide some kind of mechanism for the users to self-register. I need to have the proper access control in place. In general, when people say proper access control, we are talking about RBAC, which is role-based access control, very common for regulated industries. Very common. It's a requirement for regulated industries. We have lots of governmental and also industry compliance rules that requires you to have proper access control in place. What else? The customer might come to you and say, "Yeah, we are going to have many users producing large amounts of data, and in this case, the chunks of data are the size of around 120 bytes, and the rate that we are ingesting this data is one chunk per user at each every 20 milliseconds." And let's say that for alien attack, the sample payload is going to get JSON with this format, right? We're going to have a session ID, the gamer ID, the score, how many shots, how many lives are left, and what's the level of the user at that specific moment, right? Of course, at a certain point, we are going to add a timestamp, so we need to know what was the moment in time that was the scoreboard for that user. And the customer is going to come, of course, with some requirements for storing data, right? They need to store the data for future needs, but they also need to consume the data in real time, right? And finally, and this is very common today, the customer doesn't want to spend time managing the infrastructure, right? They want you, as an SA, as a solution architect, bring to them some kind of solution or automation mechanisms or whatever you want, manage the services to minimize the costs with managing this environment, right? So let's start the discussion talking about the concept of real time, right? Because in the title of the session, I've written there near real time. What's the difference between near real time and near real time, right? Let's
Hey,
go
Fabian.
with that. So,
I think your mic is crackling a little bit. It might be like hitting your shirt or yeah.
No, let me see. Oh yeah, maybe, probably. Let me hold it
Okay.
here. It's better. It's better now.
Yeah. Yeah.
Yeah. Let's
Okay.
let's ping me again if that happens again. Okay.
Okay.
Okay. So one important thing is that, first of all, for our applications, you are going to need to store data forever. If you go nowadays to your BI people, your big data people, your data science people, and you tell them, hey folks, I don't have enough space on my storage. I need to get rid of some data. Can you select some data to be thrown away? Man, these guys are going to go crazy with you, for sure. Because you don't know, right? The information that you're starting today, maybe it doesn't make sense right now, but from a long-term perspective, if you look at that data 6 months, 1 year from now, you can start identifying some trends. You can use the data to train AI models. You can use the data to run data science models, and you can identify a lot of learnings, a lot of information that might be helpful to your team, for your company, to select the best customers, to design new products, to improve your customer experience, to identify how your customers are consuming your services. So there's a lot of opportunity there in historical data, right? You need to start that. But also, for the data that is coming right now to your environment, right? You need to, if you have access to real-time data and you can process it, this is super valuable for your business. And depending on your business, this might be very critical. So let me give you an example to help us to understand why it's important to think about real time, near real time, and why it's important to go to your customer and ask the customer, what means real time for you? That's a super important question from the perspective of requirement analysis. So think about this. Think that the customer comes to you and say that they need to build a system to track the status and make configuration adjustments to improve the performance of a NASCAR or a Formula One car on the track. So you are on the track, running the race, and you need get data, process data, and send adjustment to the car, right? What means real time for this scenario? What means latency for this scenario? So think about the expected sampling rate for the sensors in the car. Think about the requirement adjustment rate to the actuators in the car, and of course the latency, right? You are going to realize that for this kind of environment, you might even require some kind of processing at the edge, something in the car, or maybe Snowball Edge, AWS Greengrass, maybe AWS Outposts close to the track. I don't know. You need to find something there on the field to process the data on the car, send that data to your team. You cannot afford to the latency of sending data to the cloud and waiting for the response back, right? So this is one case. Another case, let's switch our mind to a different scenario. Same architecture, but different scenario. Suppose that you have just created an IoT device to track your pet, right? And your pet Just to guarantee, for example, that this pet is not going to run away from home, right? This pet is a tortoise. What means real time for this scenario? Do you really need like millisecond or microsecond response time to track your turtle? That's an important, what's the sampling rate that you need to have for this scenario, right? So the concept of real time is strongly dependent on the phenomenon that you are observing. And you need to ask that for your customer, because if your customer comes with something like this kind of requirement here, right? You need to ask your customer, what means real time for you, right? So that's an important question. Once that we are receiving the data, another thing that we need to think about is what kind of processing we are going to do over this data. Is this message processing or is this streaming processing? And what's the difference? So message processing, the messages are individual. You don't need, they are totally independent or of each other. You don't need to worry when you are reading and you are receiving and processing a message, you don't need to worry about the other messages. You don't care about it because they are not correlated, right? But if you're thinking about stream processing, then your unity of work is not the message anymore, it's the stream. So the messages might be coming from different users, different endpoints, but they are somehow correlated, right? You need to analyze the streaming for a certain purpose. Sometimes the same application, for the same application, you need to have both views. So let's think about, for example, processing financial transactions, payment transactions, right? One payment coming from Fabian is totally independent from a payment coming from other person, right? It doesn't matter. So if I'm buying something right now at Amazon.com and James is also buying, from a perspective of, from a user perspective, this is not important. So they are going to treat each one of these messages individually from the perspective of processing the payment. But from a fraud perspective, if you are seeing that we are having different messages coming at, let's say, 10 minutes time frame, they are coming from the same IP, same source, different users. So depending from a payment application, this might be strange, right? Maybe we should take a look at this. Can be a lot of people coming from behind the same public IP, right? But I don't know, depending on the case, can be someone coming from a different scenario. Or if I have the same user coming from different place at the same time, in a time frame of 10 minutes. So we have one transaction coming from New York, another one coming from Baltimore, another one coming from Brazil. So we need to check that. So depending on the nature, the same application, the same system might require both pipelines there, right? So related use case, which are the same architecture for LN attack. Think about near real-time sales reporting. Think about beacons in retail stores. Think about payments or any kind of financial transaction processing. Think about IoT applications at any case, right? Think about at home, hospitals, healthcare systems. Think about anything you want, like car, ride-share applications, anything. So gamification, of course, you need to compute a scoreboard, something like that, and many more, right? Think about different scenarios. we are going to face the same architecture. So let's look at this architecture from different perspectives. Think about high-level block architecture, right? We have some kind of secure mechanism taking care of this environment. We have some front end, right, for producers and for consumers, maybe the same application, maybe different applications. One is web, another one is mobile. It's not important, right? Uh, so we have an ingestion mechanism to put data inside the environment. We have a processing layer where we have some kind of mechanism there, crunching the data and getting more information from it, right? Statistical data or identifying fraud or anything in the domain of the business. We have something there to store the data, and we have something as well to allow the consumers to connect and consume this data, or real time, or data that was stored already, right? And to maintain this information, independently of what we choose here, we need to cope with operation, security, reliability, performance, and cost of this environment. And this is something that we as solutions architect, we need to take care of. We need to come with the solution, and our C-level are going to ask us, okay, great solution, great design, beautiful diagram. Okay, tell me how we are going to manage that. Tell me about the security of this thing. Tell me how this environment is going to scale. Tell me about the performance and tell me the cost per user, per API request, or per payload ingest. So I need to have that information, right? This is important for me to come up with some costs or pricing for the end user. So this is going to be the same high-level block architecture for a variety of applications. Let's look at this from an infrastructure perspective, right? So if you think about the infrastructure, so you need to have some servers there. You need to put some virtualization layer there. I don't believe that we are going to find somewhere a data center where people is not using virtualization. I don't believe that. So on top of that, we are going to have some VMs, right? Which are our virtual appliances. And on top of these VMs, we're going to have database selected for the environment, platforms like, let's say, Kubernetes or Docker or maybe application server, something like that. We need something to cope with authentication, like Active Directory, LDAP, I don't know, right? Access control. We need to have something to provide APIs. We need to have web server. We need to have application server. We need to have a lot of elements there to take care of our border infrastructure, DNS, firewalls, IDS, IPS, networking. So in general, when people are developing systems, they are not thinking about all this, right? This was on the past. Nowadays, we need to think about all this because all these elements are going to scale up and down depending on the requirements of your depending on the load that is hitting your environment right now. So for example, we have like how many people playing? 10 people here playing Alien Attack. So if we have this workshop running at a global scale, right? This session running at global scale, we had like 1 million users. How the Alien Attack infrastructure would be able to cope with that, right? So the solution for that is, I'm going to be very fast with this because I believe everyone here knows about this. First step, cloud computing. You know about moving CAPEX to OPEX. You know that is not thinking more about cost, it's about TCO. So when someone comes to you and say, hey, so the cost of this environment on the cloud is more expensive than my cost on my on-premise infrastructure. If this person is not talking about TCO, they are not comparing the apples with apples, right? They need to think about TCO. They need to be able to respond the answers related to CO, and most of these levels, they don't know the CO for their applications, right? And something that's very important with cloud computing, the two words that I like most here are elastic and automated, right? If you are coming to the cloud and you are not implementing an elastic environment and you are not worried about automation, you are not using cloud, right? When you see, for example, a customer doing a migration, lift and shift from on-premise to the cloud, right? They are just getting the servers that they have on the cloud, on-premise, and moving that to the cloud. They need to think of this movement as like the embryo for what they need to do for it's just the first step of the journey. If they are not using elasticity, if they are not implementing automation, they might be burning money, and a lot of money, right? So it's our responsibility as SAs to design that. It's our responsibility as AWS SAs to help our customers to design, to implement that in a way that's elastic and automated. And it's the responsibility of partners like Contino to help our customers to implement systems like that, right? And why we are coming with serverless, right? Is the main reason for that is that requirement that our customer brought to us today. They don't want to spend money managing the environment. So in general, when you are using serverless, of course, down there, we have servers. But when we are talking about serverless, it means that we don't need to worry about that. So there's some kind of mechanism there already designed that is going to take care of patching, of updating the environment, of taking care of scaling up and down. Probably you are going to have automated backups for that environment. Probably DR is going to be there by nature. So there's a lot of things that we need to take care of if you are not using serverless. That is already there. That's why it's going to be important for us to use serverless. So if you think about that data center vision, right? Like looking to all the elements that we have there. If you are designing systems, you just need to worry about systems and applications. You don't need to worry about anything else. You don't need to worry about DNS. You don't need to worry about firewalls. You don't need to worry about networking. You don't need to worry about scaling up and down, databases, container layer, and so on. Right? You just need to focus on responding to your customers' requirements, to implement solutions or implement features that are going to satisfy your customers' requirements. This is going to reduce the TCO a lot, right? So when you know that you are going to the cloud and you know that you are going serverless, so when you get back to this vision of your environment, your next discussion is going to be, okay, Fabian, good. So I know that we're going to have the ingestion layer, the consumption layer, processing layer, storing layer, and we need to host this somehow on the cloud. So tell me what to choose. I know that AWS has more than 150 services there, and man, it's crazy. No, we are giving you a lot of opportunity to select what's best for your company, because it's not just about going serverless. It depends on how much you have invested in training, how experienced your team is with a certain technology, what's the moment of your company, what's the culture of your company. So what's the long-term, what's the strategy, the vision for the digital transformation of your company. So selecting the proper service is a combination of a lot of different things. That's why some companies just do lift and shift, and other companies look to their environment and say, I don't want to do lift and shift. I want to transform my environment and go serverless from what we have on-premise to a more cloud-native environment on the cloud. So there are different cases here. And to help you to understand that the proper services is something that we at AWS and our partners can help a lot, right? So we are going to go through each one of these layers right now, right? Let's start with the hosting. Let's host the website, right? Pretty straightforward here. Very, very common solution here is, or you are going to have a server with a web server, a virtual machine with web server, right? Or we are going to have containers with a web server on top of some kind of host environment. This is the most common implementation on premises. If you're going to the cloud, if you're coming to AWS, if you think about alien attack, a lot of static assets. We have HTML, CSS, JavaScript there, right? We could use, of course, container with Nginx, Tomcat, I don't know, Apache, or anything you want. But if you think about this kind of deployment on AWS, the most common elements here are these three. So you have Route 53, which is the DNS. So serverless.alienattack.ninja is coming from Route 53, right? You have CloudFront, which is the CDN to support a global distribution of this environment. So is a content delivery network, act as a cache for this environment, improves a lot the performance for the first byte of the web page, and also acts as a, let's say, a global proxy for our APIs, right? And S3 to support to hold those assets, right? So I'm going to give you some sample pricing. So this might be outdated. In general, we have price reduction from time to time. This price changes or varies from region to region. That's not important. I just want you to be aware of like how much this might cost depending on scenario, and for you to think about the do yourself strategy, right? If you think about, okay, I'm not going to use S3, I'm going to build my own S3 on top of 3 data centers. I'm going to build my own environment and support my services. So can you go and build something from a TCO perspective, which is closer to something like this, right? If you are thinking about implementing your own highly available 100% SLA DNS service, when you think something about this, do you think that do-it-yourself approach makes sense? It's very difficult for most of the companies. I'm saying for the most of the companies. You see that certain companies like, for example, which are customers of AWS, Netflix, Airbnb, at certain point, these companies go and they even build their own databases, like the real engine, right? They fine-tune their own operating system. So this is they become very specialized at a certain point, right? So this is a different thing, and even these companies, they are still running a lot on top of AWS, and even this very specialized framework that they build, they still have those environments running on top of AWS. They are a different thing, right? They do a lot of do-it-yourself way for things. But in general, for most of the companies doing things that are not very business focused, create your own structure for DNS, your own structure for CDN, your own structure for object storage is super complicated, right? So if we start building blocks for our architecture, so we are going to have something like this. So to support the website serving here, we have these 3 elements, and we are going to start building the architecture for alien attack, which is going to be the same architecture I told before for different scenarios. Okay? So let's go to the security layer, right? So first question here, have you ever built an access control system yourself? Let me get back here to the, let me jump here and go to the next pool. Let me give you a few seconds to answer this, right? Go there and tell me, have you ever built an access control system yourself, like from scratch?
I posted it again in the channel for everybody,
Cool,
for new people.
cool. Let me put the response here so we can see how many people is answer here, right? 3 people. How many people we have here today? Oh, guys, let's go answer this. 5 people. Just 5. Probably people is joining.
They're probably trying to. No, I don't see. I see a couple people still playing. I was say they're probably playing the game and not and not answering your poll.
Yeah, I see. Chris is playing the game. He's trying to get it shirt. I know. I'm going to give you. So at the end, while we are going to the Q&A, and maybe have some beers. In my case, I'm going to have some beer, and we can play a little bit more, right? See if you can beat Tyler. 8 people. Let me see. Let's go, people. This pool is totally like I'm not getting your email or nothing like that. I'm just getting the answers. 9 people. Okay, let's go with it. Some people, 32%, have built their own access control system. Most of the people have not built. Okay, so
a lot more
I
than I
have
thought it would
built.
have been.
Yeah, so I have built some like, and it's crazy, man. It's super tough, right? So this is going to be later. So it's super tough. There's a lot of things that you need to take care of. You need to have a team in general responsible for managing that environments or build application. Is not a very simple application. If you think, it's just users and like permissions. No, it's not just that. For sure, it's not just that, right? So let's get back to AWS to Alien Attack. I think about how we could build something like that, right? So of course, do-it-yourself approach to access control system. Good luck. God bless you. God help you, and maybe procure some third-party tool and implement those tools on top of VMs, right? Or install that on containers. Or for some cases, you have Okta and other companies which are AWS partners as well that provides you some mechanisms to that. So, but what we have natively on AWS, 2 services to help you with that. One is Cognito, and another one is IAM. These guys work together, right? You can have IAM connected to Cognito. IAM is going to provide you is helpful to provide a lot of security guardrails for your infrastructure, but it also provides you the policies that you need and roles that you need to assign to create give permissions to groups that you can create on Cognito, right? So just to give you some idea about the pricing, for IAM, there's no cost there, right? And for Cognito, Cognito have everything that you need to build your access control system with RBAC controls. There you have second factor of authentication, can integrate. You have federation with Active Directory, Facebook, or other OpenID providers. So there's a lot of options there. The first 50,000 monthly active users are totally free. So for Alien Attack, probably is going to be free forever. Because I don't think that we're going to have at a certain point 50,000 users playing at the same time or actively using Alien Attack, right? And even if you go over this 50K, it's super inexpensive for each additional user, right? The way that we define that with Cognito is like this. right? We have user pools, which is where you define your users and you define also your groups. So for the case of Alien Attack, we just have two groups: the managers, the people, those that are managing the scoreboard, creating the session, have access to create new managers and so on, and the players. So they can join the game, they can play the game, but they don't have access to the analytics part. They cannot create sessions. They don't have access to the dashboard, managing the environment, for observing the environment. You don't have anything like that, right? And with identity pool, you can create rules that say, for example, if you have a user coming from this group, assign this role. If they have users coming from this other group, assign this role. And you have users from that belongs to this, at the same time to both groups, you can create rules to decide which one is going to be the most appropriate profile for that user. Inclusively, you can say, oh, if you have someone coming from 2 or 3 groups at the same time, block this guy, something is wrong. You can just configure that. It is totally serverless, right? There's a lot of features there on Cognito. So if you want to do a deep dive on Cognito, it's probably going to be like 4 hours or more of discussion on Cognito. But it's a very effective to build this kind of scenario, give permissions to users. So what we have right now on Alien Attack is having, from the manager side, we have the AWS SDK for JavaScript, and they are using Cognito to access the environment. And from the gamer side, same thing, SDK for Cognito, for SDK for AWS SDK for JavaScript, accessing Cognito directly. So they are not going through any API, is accessed directly the Cognito API, retrieving the permissions to access the environment. So everything that you did on the game, register yourself, sign in on the game, sign up, sign in, and in the future, if you want to get the code and play with a little bit with Alien Attack, you can build like mechanisms to, I forgot my password, I need to block these users, and you can create more things there if you want, right? I'm going to talk about this at the end, but we have an immersion day with Alien Attack, which you can deliver to your company. You can talk to James at the end, and we can organize that to your company if this makes sense to you. So this is the security layer. We just have this there. And with that, we are going to give permission to the user to access everything, all the resources that we are going to build on the ingestion consumption layer, on the processing layer, on the storage layer as well. So let's talk about a little bit about the ingestion consumption layer, right? How to push data and how to consume data from this environment. What comes to your mind, right? Common patterns here for this one, the same. One very straightforward pattern is using API gateway, right? AWS has a service named API gateway, but in fact, this is a name of a microservice architecture pattern. We just use the same name for our service, right? You can build one API gateway yourself, running on something like Nginx, Apache, Node.js, Python with Flask, or other frameworks. There are many options here, right? You can host on EC2 instance or container if you want, right? If you want to build another option, you can, for example, use a GraphQL engine for this as well. A GraphQL provides you mechanism to integrate, is a specific framework that provides you some semantics and mechanisms to crawl different APIs and different data sources and consume data from different sources at the same time. It also is able to provide you some real-time data connection via WebSocket, for example. If you're thinking about stream processing, you can think about Kafka or maybe Spark. And if this application is IoT, you can think about IoT gateway. You can procure from companies, use AWS, you decide, right? You can do it yourself, build yourself one, right, if you want. Many options here, right? But if you think about serverless on AWS, there are some clear elements here. First one, as the name says, API gateway. Fully managed service on AWS, make it easier for developers to create, publish, maintain, monitor, and secure APIs at any scale, right? Provides a lot of mechanisms for integration. We're going to see a little bit about this later. Another one is Kinesis streams, Kinesis data streams. Is massively scalable and durable real-time data stream service on AWS. You can capture gigabytes of data per second if you want from hundreds of thousands of sources. You can make the data available in milliseconds to enable real-time processing for all needs, right? Beyond that, an interesting feature of Kinesis data streams that you can store data for 24 hours by default, and you can configure to store the data up to 7 days if you want, right? Let me see what else. Another option that we can have here. Of course, IoT. IoT is another option here. If you want to ingest data and consume data, it's the same. Super good for connected devices to securely interact with cloud applications and other devices. And another one is AppSync. AppSync is our solution for GraphQL, right? Super interesting capabilities for API integration and WebSocket, super good for OS. And finally, recently we have released Amazon Managed Stream for Kafka, which is basically a managed Kafka cluster for your environment. So we're not going to talk about AMSK, which is Managed Stream for Kafka, because it's based on servers, and we want to go serverless. We don't want to worry about servers here, right? So our options here are API gateway, Kinesis data streams, and IoT core and AppSync, right? All of them might be a fit for this architecture, right? So the prices are here. So depending on the ingestion rate, how many users you have, you need to do some math to go to the cost. But suppose that the costs are going to be very closer to each other, right? What would you select here and why? Most important, why? Why are you selecting this or that? So at the end, if you want to ask, oh, why I'm not using IoT Core, or why are we selecting IoT Core? Or Fabian, why we are not selecting AppSync anymore? Why we are using AppSync? We can go deeper on that later if you want. So next pull question. What service do you recommend for the ingestion consumption layer? Let's go here. Let me give you a few seconds to answer this one. Let me create some bias. Kinesis data stream, 100% of one person. We need more. AppSync in front of Kinesis data streams. Now we have a challenge here. Six people. I need more.
See, in person, I usually just throw shirts at people. Ask CJ.
Yeah, I want to see you do that virtually. We need to find a way of doing that in the future, right?
Yeah.
We can make a game to that. You can throw a t-shirt and you need to go to the screen and capture the t-shirt.
I've seen it on like Streamlabs, they have like a pinwheel that you can spin and give things away.
Nice. Cool.
Yeah.
So 7 people. Let's see the responses here. So we have, I'm not sure, we have AppSync in front of Kinesis data streams, and we have Amazon Kinesis data streams alone, 71%. Cool. Let's talk about this, right? Let's talk about what we have selected uh, to AWS, to Alien Attack, right? First of all, we have selected API Gateway in front for the gamers, right? And we have put Kinesis data streams behind API Gateway, and we have provided a direct connection, so a direct mechanism, a directive path of access for the manager to consume real-time data from Kinesis data streams, right? So the question here is why we have selected that, and why not API, why not, let's say, why not Kinesis data streams alone, right? Why not IoT, right? I'm going to give you some quick answers to these questions, and we can talk later more about this. So first of all, if you remove IoT gate, API gate, sorry, right? If you remove API gate and you put Kinesis data streams in front of a web app, right? And you give permissions to the users to write to Kinesis data stream, first thing is going to happen. Kinesis data streams doesn't care of what kind of payload you are sending to the environment. So it doesn't do any kind of validation on the payload. So if you give permissions to users, gamers, to write directly to Kinesis data streams, people can write anything they want to write here, right? So if we do that, we need to implement something here at the processing layer to validate the data, to validate the payload and identify probably possible misusage of your environment, of our environment, right? So if we put API Gateway in front of it, first of all, API Gateway provides you native mechanisms to, first, access control is integrated, highly integrated to Cognito. So when you give permissions to people here, you can come and say, okay, if someone is from the manager group, give permission to do this and that. Is a gamer, just give you permission to these other APIs. First of all. Second feature, API Gateway can validate your payload. So you can define a model for your payload, and if this model is not, if the payload is not compliant, API Gateway is going to drop those the payload. Finally, it's super simple to integrate API Gateway with mechanisms like WAF, Web Application Firewalls. So to prevent distributed denial of service attacks and other kinds of attacks, right? So from the perspective of security, that's why we have API Gateway here in front of the users, because we trust the managers. They are people responsible for an environment, so they can access Kinesis directly, especially because we are giving permissions here just for them to read from Kinesis. So this is the first reason, right? And it's the same for example, why we are not using IoT here. This is web application. And the way that we give permissions for devices is via certificates. We could give permissions for devices using Cognito as well. Think about mobile apps. You could do that, right? But at the same time, you are going to hit issues if you give direct access here, right? And another thing is from the perspective of IoT, the best way of manage that is via certificates. That's why we don't recommend this kind of like exposing mobile apps or web apps directly via IoT device, via IoT core, especially unless you have some very clear requirements there. What else? Next. So other questions, post on the chat room, and we are going to go through it later, right? Why not AppSync, right? Because IoT Gateway is super simple. We don't have a lot of requirements in terms of different data sources. So right now, API Gateway is the best solution for what we are building right now. So, but remember, the architecture for today is not necessarily the architecture for tomorrow. If you do an architecture review on this environment 6 months from now, it might be something totally different. You might decide for changing this environment for AppSync, right? And so that's why important for you to build an environment in a way that's very easy to change your architecture if you want. That we are talking about infrastructure as a code, using Terraform, using using CloudFormation, or using CDK, which was what you're using here with LNAttack. Okay, let's talk a little bit. So API Gateway, just to give you a quick overview about API Gateway, super highly integrated for REST applications, super easy to integrate with different services. You can put API Gateway in front of on-premises resources if you want, right? So it's simple to integrate with your on-premises applications. And we have features for REST APIs, for WebSocket APIs, and we have released last year the simple HTTP API, which is going to reduce the cost a lot for API Gateway, right? And we have also Kinesis streams. The way that Kinesis streams scales is via the shards. So one shard gives you 1 megabyte per second in and 2 megabytes per second out. So we have here for a single shard, you have 1 megabyte in and 2 megabytes out, right? And you have here an ordered stream of events that you can have different consumers consuming data here, right? So this is super powerful, super highly scalable. The only thing with Kinesis data streams is that there's no auto-scaling for the shards. So you need to implement that. And the reason is because it's highly dependent on the nature of the application. So for example, the best way of scaling shards up and down for LNAttack is not by looking at the ingestion rate here. As we have people joining the game, as we have people, the manager can hold the session and start the session for everyone together. The best way is just looking at how many users I have. I know what's the ingestion rate for users, and then I can provision the shards right away, right? And after that, I can also look at the ingestion rate that is coming from the different users. If we have more people join at a certain time or people leaving the game, I can start scaling down the environment or scaling up if I want. So I need to implement my own strategy for scale up and down, right? It's not as simple as, for example, for servers, which is basically based on queue size or memory or processor for most of the cases. Cool? So let's talk about the processing layer. Processing layer, same thing here. You can do it yourself, use VMs with application server, or VMs or containers with application servers. You can use third-party frameworks running or third-party application servers running on top of VMs. You can use third-party frameworks or application servers or web servers or anything you want running on top of containers. But on AWS, you can have different tools for that. First one is AWS Lambda, right? Lambda is a service that allows you to run your code without needing to think about servers. Is basically function as a server, as a service, right? You don't need to think about containers. You can get your code and you can write your own code and wrap that code as a library and put that on Lambda in a way that in the future you can port it to containers or move that back to your on-premise environment. So there's no lock-in here, right? Is another discussion when we talk about serverless, is about lock-in, something that we can discuss at the end. Probably you guys are very aware of what means to each one of you. Another element here is Kinesis data analytics, right? With Kinesis data analytics, you can run SQL-like statements over stream data. So if you are experienced with Spark QL, it's kind of the same, but it's a managed service that we have here, right? It has built-in functions that will allow you to run queries that you can examine data using sliding windows. So you can, which means that you can apply functions over blocks of data of a certain size over time. You can implement like some mechanisms for anomaly detection, which is super easy to implement fraud prevention, for example. Right? You can do that with Lambda, but with Lambda, you need to write code. It's not a SQL-based implementation. And finally, if by any reason you want to use your containers, because maybe you already have it in containers, maybe because your company is totally focused on containers, so go to Fargate, right? Fargate is a compute engine for Amazon ECS that allows you to run containers without having to manage servers or clusters. Super simple, right? So if you think about a pricing perspective, the way that we price that, Fargate is per minute minimum. With containers, you need, of course, to have at least one container there and then let your environment to scale up and down, depending on how you implement your scaling up and down strategy. Kinesis data analytics, you need to have that. It's per hour, so it's going to be running all the time, and is based on the configuration number of vCPUs and memory that you have there, and you can scale up and down as well. And with Lambda, we have free tier. We don't have that for these other two, and you pay per request. Some companies are running on top of Lambda under free tier. Yeah, right? So if you think about alien attack, which service you are going to use for that? Right? Another pool here. Let me open it for you. So we have Kinesis Data Analytics, Lambda, Fargate. No, I want to go with ECS. No, I want to go with EC2. No, there's other thing that you have not mentioned here, Fabian, and I'm not sure. Right? Let's see. Let me see the numbers. 2 people, 3, 4, 5. More. Lambda, I'm not sure. 6, 7, 8, better. Lambda, 88%, 13%, I'm not sure. So, what we have chosen here, our thing is in fact Lambda. So we have Lambda as a processing layer here, right? And the way that we are integrating Lambda here is, first, we have Lambda processing some events coming from API gateway. For example, when you are joining the game, I'm allocating your seat. When you leave the game, we are deallocating your seat. So it's a way of triggering scaling up and down for Kinesis data streams, right? And another thing that Lambda is doing for us here is to do the consumption of Kinesis. So the way that we are processing the storyboard and in storing the scoreboard as we see the scoreboard in near real time is by having Lambda getting a batch of data from Kinesis data streams, computing the scoreboard, and storing it on the storing layer. So, in fact, we have two, when we have with this data stream, two consumers. One consumer is our manager, our scoreboard is consuming Kinesis here, and another consumer is Lambda. And this is a native integration between Lambda and Kinesis. Of course, we have different functions taking care. One function is taking care of allocation, another one taking care of the allocation. Maybe it's the same function, I don't remember. I need to check the code again. And I built this thing, I don't remember anymore. And we have another function taking care of this path here, right? So Lambda, we have event source, which can be change in data state or some requests coming from API gateway or changes in the resource state. So, for example, think about integration with CloudWatch events or bridge event. So, for example, if you have something coming from Event Bridge, some event coming, you can react to that. So, for example, it's the way of implementing continuous compliance, continuous security, continuous governance. Is a good way using Lambda and Event Bridge or CloudWatch events and Lambda, right? So that's why people on security field, people on infrastructure, you guys need to learn how to program at least with Python. We have some options to program your functions. Node.js, Python is super friendly. We have Go. James loves Go, I know it. And you can bring your own environment. So if you want to run COBOL on Lambda, you can. There's COBOL Lambda. If you search that on Google, COBOL Lambda, you're going to find something there. And then Lambda can integrate with anything, on premises or in the cloud, right? Or other SaaS services, if you want. And the way that the execution model here, we have 3 ways of integrating. We have 2 of these ways we have on LN attack. One is synchronous, so a request comes from API gateway. You have a payload there. This is received. We have a certain resource on API gateway, and we send that to Lambda to consume and process and send to other elements here. Another one is a pool-based. So the integration, for example, with Kinesis streams happens like that. So we have the Lambda service is not you. We have Lambda service from time to time going to Kinesis, retrieving a batch of data, sending this batch to Lambda send this batch to the Lambda function, and you're going to process this batch, and you do anything you want with that. So we have this one in AWS right now, with LN attack right now, and this one as well, right? Why not Fargate? Because we don't want to pay for anything we are not playing the game, right? When I close the session, the environment is shut down, just that. Why I'm not using Kinesis Analytics? Because right now, I want to write the code for Lambda, and I don't need to pay for anything if I have nothing running there, if I'm not running a session. Just for you to remember, with these 2 folks here, Kinesis Data Analytics and Fargate, you pay even when you don't have any environment running, because you need to have something there. You need to have at least one container there to respond to your first request. If you try to trigger that container, maybe it's going to be a little bit more complicated. You need to be more implement some automation. Is possible as well, but probably the latency is going to be higher than the one that we get with Lambda, right? So this is our architecture. See that our architecture is taking form here. So let's go to the storing layer, right? You can, of course, If you want to build your own database, yes, have fun, right? Some companies are doing that for their specific needs. They are releasing those engines as open source in general. Or, of course, this database is going to need some kind of block storage or some kind of object storage, so you can store the raw data. You can have that running on top of VMs. You can have that running as managed services. I've seen some people running database on top of containers. I don't like that a lot. Some people say, oh, yeah, I can do that, but you know, I was a professor for 20 years at colleges in Brazil, and I used to say for my students, it's not because it's working that's correct, right? It's different. Sometimes what works right now, when you think at scale, when you think at long term, when you think about CCO, and if TCO, and you think about other requirements, is not correct from a distributed system perspective. So some options here, right? We already have one thing there. Kinesis data streams store the data for 24 hours. We have kind of a caching layer already for our environment, right? We can rely on that for 24 hours. And if you want to go over 7 days, okay, right? And after that, you can move to different environments. Depending on how we design this, maybe Kinesis data stream is more than enough, right? But you need to have some kind of some database. For example, for alien attack, we need to have the scoreboard, the computed scoreboard stored in a database right now, like a snapshot of that scoreboard that we had presented for you on the screen. So, which database we could use? So we have some options for relational databases, right? We have Aurora serverless, we have RDS, we have Elasticache. Elasticache is not like is not relational, but it's our core. Let's say that's very generic databases, multi-purpose databases. Redshift as well is multi-purpose, but is more indicated to BI environments. We have like specific purpose database as well: DynamoDB, DocumentDB, Neptune, TimeStream, QLDB, right? We also have some other resource that can help you to implement storing mechanism where you can store data. I don't know if you guys know about this, but for example, we have on System Manager, we have parameter store. So with parameter store, instead of saving your application configuration, something that we used to do all the time, create a like config tab or config table on a relational database to store the application configuration, we don't need that anymore. We can use System Manager instead, right? If you want. Oh, if you want, you can create a table on DocumentDB or DynamoDB if you want as well. So really depend on how you test environment. And of course, if you think about the raw data for this environment, S3 is a good thing there as well to store the environment, right? So, which database you are going to select for this environment, right? See, a lot of options here. Let's go to another quiz and see what you are going to select here. So we have RDS, we have DynamoDB, Redshift, DocumentDB, Neptune, QLDB. I need more than one database to attend the requirements. Oh, this is a good one. None of the options is acceptable, and I'm not sure. Let's see how many people here. 4, 5, 6, 6 RDS, 70%. More. I need
RDS
8
is a
people.
little overkill.
Right? 7. One more, at least. Let's go. Let's go. DynamoDB, none of the options is acceptable. So I want to see a question about this. Why not? So why not this other option, which is better for this scenario, right? Go there, put there, and we're going to talk about this later. So let's see what we have selected for alien attack, right? So let's start with the group at the top, right? So the nature of the data coming from the gamers does not appear to be relational. So it's a JSON payload, right? If you want to query the data about the sessions, probably you're going to choose the session ID or the player ID or timestamp. So RDS, these guys on the top seems to be highly overkill, right? If you go to the documentation of Elasticache, you are going to see, oh, Elasticache is super great for scoreboards. So why not use that for alien attack? Simple reason. We want to go serverless, test it at scale, and check if it works for our customer. So our go-to architecture is going to be something that's not Elasticache. So something that's very common with customers working with us, with AWS and with our partners, is having a partner going to the customer and say, hey, considering the requirement that you have provided, I think that having this architecture, they provided an architecture diagram, is going to be the best one, right? What do you think about doing a POC with AWS so we can test this environment at scale? So we can do a POC with a partner, and we can have AWS funding this POC with the partner, so you don't need to pay for that. So it's a great way of testing your design with your partner, validating your requirements before going to prod. It's super a great opportunity to learn more about your design, and it is super important when you are doing redesign, when you are doing not a lift and shift, you are changing your architecture to move that to the cloud, right? So it's not a relational database, so it doesn't make sense to have Aurora, and it's not a columnar database. It's not a BI application, so it doesn't make sense to have these guys on the top, right? Let's see the guys down there, right? Let's see at the bottom. We will exclude, of course, Neptune for two reasons. First, there's no graph here right now. There's no graph nature. Maybe in the future, if you're going to track a relationship between gamers, between sessions, something like that, like have teams or something like that, maybe in the future. But right now, there's no requirement there, right? And second, Neptune is managed, is not serverless, right? You need to choose the instance size. So it's not the best fit if you want to go fully as much serverless as possible. QLDB is not a solution, right? It's not an indicated service right now because there's no strong requirement regarding tracking transactions or changes to data. So there's no compliance requirements here. If you need some kind of compliance requirements, so think about you are talking about a financial application. If this would be a financial application, maybe QLDB would be there, right? Let's see what else. If we're talking about JSON, so at the end, we're going to have maybe DynamoDB, DocumentDB, or TimeStream if you're doing a lot of queries on timestamp, right? We don't know yet if you need TimeStream. So the payload is very small. DocumentDB is only if you have very big, very large documents over 400 kbytes, right? So 400 kbytes. So if you don't have anything below that, DynamoDB is more than enough. So let's start with DynamoDB. It's a great choice to start with, at least to a POC, right? Let's use System Manager to store the information for the configuration of the game. And we have another element here, which is Kinesis Data Firehose, which is going to help you to move data to S3 at the same time. So you're going to have two paths. One path is near real-time ingestion, and another one is the embryo, the first step to create our data lake. So thinking about the pricing here, Kinesis Data Firehose, you pay for the volume of ingested data. System manager parameter store. There's no cost here, but you need to test that at scale because you might face uh, some constraints in terms of how many requests you can have on system manager at the same time. And DynamoDB, so it's key value. You can also use a document database if you want. And super important, super nice about DynamoDB, you have outscaling there. It's super cheap from a perspective, from a cost perspective. You have an interesting free tier for the volume of data that you can store there, and is running on top of many AZs at the same time, and is fault tolerant. You always get single digit millisecond, under 10 milliseconds response time from DynamoDB. So this is super important for near real-time applications if you want to build that, right? I'm not going to spend a lot of time talking about DynamoDB. I want to go to the questions at the end. And just to be quick, to talk very briefly about Kinesis data for hosts, you can ingest, transform, and deliver data to different elements. We are using S3, but you can deliver as well to Redshift, deliver that to Elasticsearch, and you can deliver that to Splunk as well. And you can have, as a source, you can have other elements like these data streams is the way that we are integrating CloudWatch logs, events, and other any sources. I've seen, for example, customers integrating these with devices, with IoT devices. So they give permission to the IoT device collect a lot of data. They provide a near real-time stream, and they provide some data to be stored on the on S3, right? So our architecture is going to be something like this, right? We're going to have Lambda storing data on DynamoDB. We are going to have, this is a very cool integration that we have on API Gateway. I like to call this codeless implementation because you just need to configure, right? There's no code here. You just go to API Gateway, you configure API Gateway to consume data from DynamoDB. It's just a transformation that you describe there, and you don't need to have a Lambda in the middle. So a direct integration. What else? We have a direct integration as well between API Gateway and System Manager, and we have as well at the end, which is a common pattern to implement your data lake. So data coming from Kinesis streams, someone consuming in real time, and you have another lag here dropping the raw data on S3 for you to consume data in real time, right? So change requests, something that never happens in the real life, right? You have a system there, you never have a customer come in and say, hey, I need to change something in the system, I need to change something in the design. Never happens. So your customer comes to you and say, I want all gamers starting at the same time. And so when the manager pushes a button there on the game, start, everybody start together. Because it's not fair having some people starting at some early moment and like training how to play alien attack, and they are going to score better. They are going to get the shirt. It's not fair. Let's having everybody start at the same time. So how to implement that, right? The way to implement that is having a direct communication between gamers and the manager, and then sending data in this channel, some kind of push notification. So we have the manager pushing a button here, and then we send a notification to everyone here, and everybody starts at the same time. Right? How to implement this requirement when you're talking about push notifications? The way of doing that is via WebSocket web server if you want. You can have this running on top of VMs. You can have this running on top of containers. Or if you listen something about push notification as well, you can think about SNS. You can think about Pinpoint, because if you read the documentation, you see, oh, I read something about SNS. I heard something about push notifications with pinpoint. So you're talking about push notifications. Maybe these guys are good as well. But WebSocket, 3 guys can implement as WebSocket as well. So IoT Core, API Gateway, and AppSync, right? So first thing here, we cannot go with SNS and pinpoint, right? Because these guys, they require you to have something running, some HTTP endpoint running at these 2 sides to keep the communication, to keep alive and keep the communication flowing, right? And there's no way, thank God, to keep at this moment a web server running in the browser. This would be like a very complicated situation from a secure perspective. So with mobile applications, okay, you have native infrastructure on the operating systems on Fire OS, Android, and Apple, or Alibaba to implement push notifications, right, on their devices. And of course, these we can integrate with SNS and pinpoint, but this is not the case right now. We're talking about web applications. So you can rely on IoT Core. Recently, 2019, we have the feature on API Gateway. So before that time, the only option that we had on AWS was IoT Core. So if that was the case, implementing Alien Attack, we would have API Gateway taking care of the REST API and IoT Core taking care of the WebSocket feature. But in the future, as we get another option, we would come after a well-architected review, we would change from IoT Core to API Gateway and AppSync. And using IoT Core, we would only give permission for the gamers to listen from IoT and manager to publish to IoT, right? And if we can build something for people to write on IoT Core on the topic, would be very constrained and like very well defined path for communication because of the secured breaches that we could have here. For example, people sending non-compliant payloads, right? So you could have IoT Core, API Gateway, AppSync. Just to give you an idea of the costs, these guys are going to be kind of the same cost, right? The main difference here is that, for example, for IoT Core, if you use the basic ingest, if you are really using devices, you don't pay for certain kind of integration. For example, using basic ingest or Alexa voice, there's no cost here, right? So, okay, another pool. What you are going to use here, right? Let me open here. IoT Core, API Gateway, AppSync, a different service not mentioned here, or I'm not sure. Cool.
Fabian, there's a question in the chat. Well, you could probably answer while people are answering the poll.
Okay, let's see. Let's see what else. One of the uses of Kafka is that it eliminates the need of a database for state data. Maybe for static data, we can use cache. Any comparative evaluation of Kinesis versus Kafka? Good question, good question. So the main point here is that first, to implement Kafka probably is going to be more expensive from a scaling perspective than when you compare that with Kinesis. First point, right? You need to have something running there all the time. And with Kinesis, we can scale that down to a single chart, which is super inexpensive, right? Another important thing is that if you need like super fast consumption, and we are doing very complex transformation, maybe Kafka can be a better option for you, right? So let me see. Taylor has answered here. That's a fair point. Kinesis you can retain open 168 hours, which can be helpful. This use case looks like being Kinesis as a conduit of near real time to be processed, then storing process output like user score, lives, etc. Don't think you'd want to rely on Kinesis to persist that to perfect. Perfect. So Kinesis is just a cache for us. For example, I'm not using the like more than 7 days feature. I just using the 24 hours and like really just the real time thing. After that, I just need to use what we have, the final scoreboard, which is on DynamoDB, or it's just to store that data, right? Which is is cheaper than like uh, having something like Elastic Cache. Is going to be less expensive than Kafka, and at the end we have S3 storing data to build our data lake, and this is going to create a lot of new opportunity for us. It's just that it's the best fit for alien attack at this moment. Maybe as happens with all applications, as alien attack evolves, as we are having more features. So think about AWS 10 years ago. Think about Netflix 5 years ago, right? Different thing, different requirements, different opportunities, and different infrastructure there, different services, right? So that's why important for you, something that the companies are not doing very much right now. We are working a lot with our customers to help with that, is that have a plan to do well architecture reviews on your environment from time to time. Some applications are going to be at 3 month long time frame. For other applications, 6 months. For other applications, at the yearly basis. It depends on compliance, depends on the criticality of the application, depends on how many changes applications have through time, depends on new features that we have. Some applications might be so critical from performance perspective that if you get a new feature or a new service, a new opportunity that is going to reduce your cost, you might have to need to do WebTech review right now because I have just released a new thing, or you are working pretty close with AWS. Or if you're a customer, you are a beta user of a new feature or a new service, you can try to run your environment in a like AB environment or Canary environment or something like that. Blue green depends how you define that, and from a development perspective. You can test your environment at scale with this new feature and decide to change to this new environment. So maybe, and we are going to bring some questions at the end that are going to help you to think about this, right? And IoT Core, someone has answered IoT Core. It works, but as we have these on API Gateway, and we have that on AppSync, would be more like an homogeneous implementation, less less like Frankenstein, to look less a Frankenstein architecture. If we stick to like a homogeneous environment, you need to learn less services, another thing, right? Think about a two pizza team. You have your team taking care of a product. You don't need to worry about different many pieces, right? You don't need to worry about the evolution of IoT Core, API Gateway. You need to worry, like take a look at it just from the perspective, from the opportunity of new features, of improving your service. But for right now, API Gateway is going to be our best option. Right, let's go ahead with it. And we're going to have an open discussion at the end. If you want, I'm going to bring some beer if you want. Grab your beer as well. So the implemented architecture for LN attack right now, right? We have our website stored, supported by CloudFront S3 and Route 53. This is stacked website. We have Cognito and Cognito and IAM providing the secured boundaries for our environment. and provide RPEC as well, which is a requirement that our customer brought to us. This is interesting. We have the manager creating the configuration for the service, and then we have the users going through API gateway and consuming the configuration for the game and consuming the session information. So that's the way that the game knows that we have a session open there, right? What else? We have API gateway being used to allocate and deallocate the user, and we have a table to store information about the user. So another thing that we need, for example, to know how many seats we have allocated and deallocated, we need to have some kind of database there. If we're decide to use something like Elasticache, okay, Elasticache would be there, but think about like it's not just about selecting the service from a latency perspective. Think about managing the environment. Think about DR scaling up and down, because DynamoDB is on top of a 3 data center automatically taking care for you of high availability. Super simple to implement multi-region DR with regional tables, and doing that with Elasticache is a little bit more tricky, right? We have the users coming from the game, posting their status via the resource update status, which is posting to Kinesis Streams. Kinesis Streams is automatically integrated to the service. Lambda service goes to Kinesis Stream and get at every second, get a batch of data and push the data to the Lambda function, which is going to compute the scoreboard and store that on DynamoDB. We have also here, for example, if I close the application for the manager, when I open the application, I log in the application, the first thing is going to the database to retrieve the stored state of the scoreboard, and then I just get the real-time updates here. So it's a good way of retrieving the previous state also, or the stored state, and then consuming the real-time updates here, right? And we have that integration. So that small screen that you have on the game on your screen, the green scoreboard with the top 10 gamers. So that's this direct integration between API Gateway and DynamoDB to consume the top 10 gamers there, right? And finally, we have this integration from Kinesis data streams, Kinesis Firehose, and S3 to create our data lake. And finally, API Gateway as our element to integrate and provide the WebSocket feature. So what we can do from here, right? We can think about security if you want, right? Shield and WAF, provide DOS and provide web application firewall. We can do some analytics here, even to manage our environment, use CloudWatch to manage environment, dashboard to manage environment. I'm going to show you that. What else? Oh, our data lake here, right, has started with Kinesis Firehose and S3. You can use Glue and Athena. Athena can give you the power of querying directly on top of S3, SQL on top of S3. What else? In the future, you can change to AppSync. You can use step function or maybe SQS for other features. And of course, to implement your pipeline, to deploy everything, to build your code, pipeline here, you can use our CodeStar elements, code commit, code deploy, code build, code pipeline, X-ray to provide observability, and other things here, right? So the questions that I want to think about alien attack as next steps, all right? So for example, if you go from 1 to 100, 1,000, 10,000, 10 million users, any changes in the architecture or in the code, right? The cost structure is going to change. How is going to change, right? So one good exercise with alien attack is get the architecture and try to compute the pricing. Do the pricing for alien attack. If you are new to serverless, it's going to be an interesting exercise because it's a kind of exercise which is the responsibility of the SAs nowadays. Session bounded versus running 24/7. So right now we are playing the game. After we finish this session, I'm going to close the session. Nothing is running anymore. But if the requirement changes to something like now we are running something that's going to be 24/7, it's going to be running all the time, requests coming all the time, Lambda is going to be used all the time. So what's going to be the cost structure for Lambda, comparing Lambda to Fargate and to Kinesis data analytics for the processing layer? Maybe if this is changing to this scenario, maybe we should change to Fargate or to Kinesis data analytics or a combination of these elements, right? If we move to more intense ingestion rates, because of course, for this game, we started with the requirement that, oh, the users are putting one chunk of data at each zero, I don't remember, 2 milliseconds, right? Or 20 milliseconds. Do you really that we need 20 milliseconds for this game? Right? We don't need that. For alien attack, maybe at 1 second is more than enough. Half of that is more than enough, right? So sometimes the customer comes to you and say, I need real time. So we need to have discussion because the rate of ingestion is going to have implications on the pricing of your architecture, the cost of your architecture. So if you have designed something for like 1 millisecond ingestion rate, and you really need just 1 second, you are going to pay a lot more for that. So you need to fine-tune that with time, not just right now. You need to save money to your customer. So in the moment of right now, COVID, right? A lot of businesses are closed. So having serverless, we can shut down everything if you want, right? So it is important to think about that. How to implement code pipeline for alien attack? It's not implemented right now. We didn't talk about this. Security is good, is bad. Where are the flaws? What needs to be improved? How to improve that? So I'm going to give you some tips about this later, right? What kind of analytic serverless architecture could come out from here? So what kind of queries, what kind of results could come from here? Oh, this is nice. It's possible to implement an AI to join the gamers and play the game against them. So think about this, having AI competing against you, right? Very nice. And what about running aware attack review for an attack? Something that we have discussed, right? So this is something that we should talk about. I'm going to give you some learning resource. Of course, AWS website, self-paced labs, quick labs. We have some labs there. We have also, I'm going to give you some labs that you can run for the partner. We have some labs that we use when delivering alien attack. Also, I'm going to skip this one. I'm going to back later. I want to thank you for the session. I'm going to go for the discussion right now, open discussion. I'm going to grab my beer. And we can also run an alien attack immersion day for your company. So it's going to be the whole day talking about deep dive, serverless, many labs, and you are going to build the architecture for alien attack yourself from the code to deploy everything, right? I'm going to open the last session, the last pool here, so you can tell me about how did we go today. Let me. Where is my pool here? Next one. Yeah. So score the session. I'm going to grab my beer and I'm going to get back to the question and answer. Right? Just a second.
I've unmuted everybody. So well, I've not unmuted them, but if you want to unmute and ask a question, you can. If you're not comfortable, you can just ask in the chat.
In the chat, yes. And I'm going to answer in the chat as well because as you can see, my my English accent is kind of weird, but don't worry about that. My Portuguese is complicated as well. So in Brazil, just to give you an idea, I come from Minas Gerais. I'm going to write the name of the state here, just if you want to research. So it's Minas Gerais. Just for you to have an idea, Minas Gerais is the Brazilian Alabama. So you can imagine my accent in
Brazilian Alabama.
So, yeah, so I'm a two country redneck. You can say that. I'm going to grab my beer.
Looks like some people are going back to playing Alien Attack, which is completely fine. Alien Attack needs to be a sticker, CJ? Or the Alabama of Brazil. Brazilian Alabama, yeah. Thanks for coming, Luther.
Cheers, everybody. A sticker from Brazil. Yeah, cool. Should be a very nice sticker. So, questions? Let me see how many people has answer here. Oh, great. Anybody, if you want to play more, the game is open, right? Want to go ask any questions? For example, it's clear for you guys why not IoT? They can, you guys can unmute yourselves.
Yeah, they should be able to.
Yeah. Cool. So let me think about. Let me open the record here just for us to think about some possible questions here.
I was just testing to make sure. CJ, unmute yourself. No? It says allow participants to unmute themselves. It's highlighted. Try it now.
That works now.
Oh, you've got to actually. Oh, I'm dumb. All good. You guys have a question? Go ahead and can unmute yourselves.
One more time with feeling.
I mean, I can click unmute all, and I heard a baby crying, so I immediately went back to just muting everyone. No, that was insightful. I liked. My favorite part was you said, "Here's the requirement. Here's what you could do, but here's the serverless answer to it." So I liked that way you presented it.
Yeah, so this is something that needs maybe a t-shirt or a sticker, right? Is the architecture for today is not the architecture for tomorrow. As the requirements change, so the customer requirements, the business requirements, compliance requirements, governance requirements, ingestion rates, I want to go global, I might need to change something on my environment, right? I might need to change from Lambda to Fargate. I might need to change from API Gateway to AppSync. And then I need to change how to implement this change in environment, right? How to improve that for that environment. So maybe one question here that I don't remember. O Birajara has talked about Ponte que you know Ponte que o Birajara. No, are you Brazilian, Birajara? Yes, right. His name is very, very, very Brazilian.
I'm Brazilian, but I can't admit right now because my daughter is just.
Oh, no problem, no problem, no problem. So let me see what else here.
Chatty.
Yeah, so for example, change from Kinesis to Kafka, depend. If you go from 24/7, if you have a lot of other kind of requirements, from a cost perspective, not from a scaling perspective, you might need to change to Kafka. But remember, Kinesis is running on top of 3 data centers minimum, right? is a regional service. DynamoDB is the same, right? API gateway is the same. So think about this, right? Think about the implications of taking these decisions and know what you're doing. Test that at scale, test disaster recovery scenarios, work with us, work with your partners to help you to think about this, right? I don't know if you guys know about this, but for example, partner SAs and SAs at AWS, we don't have goals regarding selling things to you. So we don't have like, you need to sell this month, this like $10,000 per month for no. Our goals are about reducing the cost to our customers. This is kind of strange, but that's why I'm at AWS, right? So I can go to a customer and say, man, you are burning money with this too. Let's move you to Lambda because it's going to be less expensive. And see, I don't want you to stick to AWS, so I'm going to wrap your code in a library and wrap that on the Lambda function in a way that if you want to move back to your on-premise environment, if you want to move that back if you want to move that back to your on-premise environment on containers or whatever, is going to be super simple, right? And if you want but API gateway, you can export that and use Swagger to deploy that on a different thing, right? So there are many options here. Let me see what else. What you guys think about data lake? Is data lake or Delta Lake? Birajara. Oh, from Databricks, right? So Databricks is a AWS partner, right? It's a very interesting platform, right? It's based on like, if you have experience with Apache Spark, it's kind of interesting as well. But again, I recommend you to do some POC and check what's better for your requirements. I cannot say that, oh, it's much better for every scenario. It really depends on the use case that you are implementing, right? So maybe today Delta Lake would be a interesting thing, but for maybe one part of the application, or maybe it's something for the future of alien attack or something that has alien attack. But right now for alien attack, I think that Delta Lake would be something like a big thing, bigger than something that we need. The combination of Kinesis and Lambda and DynamoDB, they are very simple to integrate, very simple to deploy. So from a TCO perspective, would be simple to implement and to manage the environment.
Fabian, can you hear me now?
Yes.
Okay. I really appreciate that slide that in the history about the turtle and the racing car. It was a really good image for me to thinking about, and I think this is a good point about the requirements, the difference between near real time and real time, and the thing that you said now. When we have this kind of architecture, a simple architecture, just dealing with the Chinese and Lambda and Dynamo, but I'm always hearing about, oh, we need more because Chinese we we can't solve everything just with Chinese and Chinese firewalls and Chinese data analytics. So we're gonna need some Spark structure, and we're gonna use some Delta Lake, and with that we're gonna build some library, and the thing is is going big, you know. And
Mm-hmm.
this trade-off between the near real time and the real time, and when we need to make some calculations, it's something that I'm really interested in right now, because I'm watching the technology walking from the data lake Lambda architecture for something more real time focused, you know. And I'm
Mm-hmm.
just thinking and seeing a lot of different approaches. We have an approach here with iFood. We are a partner. We have a great partner with AWS too. But the projects are evolving, and it's like I'm watching all this trade-off between real time, and the calculation. And we need to do calculation from 4 days, and so I don't have the solution. I have this feeling about, as we are just touching, and we can't see the problem in the big picture, like we had before with the big hive map reduce and Spark, and in
Mm-hmm.
some point, just everyone just started to make the choice for the Spark. I don't know if I was clear, but it's a
Yeah, yeah. I
subject
think
that
that I think that I got your question. So again, it is complicated to have uh, like when I show you this, for example, when I show, let me project the architecture here just for you to remember the full architecture for an attack, right? Let me put here
cool.
when we can talk over it. So this is a pattern, right? We could use this as a reference architecture to build many different applications, right? Think about
Yes,
this.
yes,
So for example, Kinesis data streams, you can go from one to thousands shards. So there's no words here about like going big with Kinesis data streams, right? And you can run, for example, you can run an application that goes record by record here, consuming. You can have one consumer going through records here and treating them in a way. And you can have, for example, another application, a Kinesis analytics application here, consuming the data like in a Spark way, using a SQL-based language. It's going to be very similar to Spark. And as you have people dropping, you have the application dropping data on S3, you can have Athena querying on petabytes of data here. So we have many customers, and something that I didn't brought here right now because of the time, and it's something like that we can do in a session with Continuous, bring some customers to you so you can understand which customers are coming with a lot of applications using Kinesis, very high scale, very critical applications. So when you say, I need something more powerful, I need to understand, for example, where you are hitting some blockers with Kinesis, right? Where you are hitting some blockers with Kinesis Analytics, right? Or where you are hitting some blockers with Athena to query like petabytes of data on top of S3. If you need query, more complex query on top of S3. So it's very common for different applications to have when at a certain point here, there we talk about how many database are going to select, maybe DynamoDB, but we might need other. For example, for the analytics parts of an attack, if you think about like a financial application or iFood, for example, you are going to need some BI there. And Athena is not to be super great for all BI cases. For that thing, maybe you are going to need something like Redshift. And in that case, Spark is not appropriate as well. So I've seen some people using, uh, running some kind of analytics queries that would be better for multidimensional models, the kind of we build on top of columnar database like Redshift. Doing that is uh, on top of Aurora, right? On top of Spark and or mixing things, and it's kind of that scenario. Oh, it's working. Yes, but it's not the best thing from a TCO perspective. When you think about managing long-term scaling as your environment grows. So for example, when I say that the architecture for today is not necessarily the architecture for tomorrow, but I don't want you to also be changing the environment at like weekly basis, right? I want you to build something today that's going to be there for maybe 6 months to 1 year, right? In general, reinvent is a crazy thing for everyone. We have a lot of new features. And with partners and customers that are working with us as beta, they start learning about service at early stages. So if you think about like a 1 year time frame, like you are going to build something to live at least for 1 year, there's a lot of space for you to do some testing. So if you have this design, suppose that I have this design right now, and at a certain point I start questioning, hey, maybe I would be better to put some Kafka here in place of Kinesis data streams, right? So let's do it. No, let's build this environment in a test environment. Let's get some data that we have here on top of S3 from the past. Let's run a simulation and test at scale. And if from a managing perspective, monitoring perspective, TCO perspective, we understand that the solution from Databricks, the solution from or Spark or Kafka is going to be better for to replace any of these pieces here, then we can go for it, right? And the best way of doing that with us, contact a partner, talk to Continuo, talk to a partner, and say, hey, I have this application here. I'm thinking about changing this to Kafka. I'm thinking about changing this to maybe Lambda to Fargate or Lambda to Kubernetes. Or I'm in Kubernetes right now. Maybe I should have gone with Lambda. I don't know. I want to try that. So do a POC. We have funding to support partners with that, right? And or work with AWS SA. I'm pretty sure that iFood has an assigned AWS SA. I don't know, almost surely. So try that, right? So don't worry about like look your neighbor, that thing, right? The grass at your neighbor ground is greener, right? Don't think like that. Test for your environment and do a real test. It's the best way of checking that.
Yep.
Make sense?
Good answer. Thank you.
Yeah, so someone asked something about like Kubernetes here, I saw. Else? Oh, yeah, cannot resist bringing Kubernetes to discussion. Do you think that it brings anything to the table, at least from scalability of processing? Yes. Two things that, first, if you are a company, if you have a team that is highly experienced and exposed to Kubernetes, man, go to Kubernetes, right? You are familiar with it. It's super, you are super comfortable with the platform. You have implemented a lot of mechanisms at your hand, or maybe you want to use Fargate if you want. Okay, go with that. But if you have implemented a lot of tooling, automated tooling to your environment, man, go with that. You know, we have Netflix presents, from time to time, we have people from Netflix presenting to AWS people the way they use AWS. And we learn a lot from them because they come and say, hey, we have this and that, and we need to build these automations and this kind of mechanism to monitor environment. This is the way that we have implemented observability, because like with this and that they are like maybe Lambda and other things, this doesn't fit our, this kind of architecture doesn't fit, or this kind of service doesn't fit our requirements. So we build new things for us, or we build this new architecture, this template, this framework, this reference architectures for our environment, and we use that in this way because for our environment is like that. So probably what they are doing maybe Prime Video is doing totally different, right? Because they have different profiles of consumptions. Their customers are different. So if you are experienced with Kubernetes, man, don't go to Lambda, right? Go to Kubernetes. And if you have more time in the future, take a look at it. Maybe pieces of your environment, you are going to see that pieces, some functions or some resource that you have deployed on your Kubernetes environment, you're going to see that they are there, sitting on top of your Kubernetes cluster, doing nothing. So think about idle, another responsibility of solutions architects. Get rid of idle. If you have some containers there that are sitting on top of your environment and doing nothing, move to Lambda. Because they can be small, but they are at scale, they are consuming pieces of your cluster, right? Move to Lambda, some parts, just from the cost perspective, from the TCO perspective. Oh no, Fabian, but this is going to give me like a more complex management environment to manage, because now I have Lambda and I have Kubernetes and I need to have pipelines for those, and I need to have test environment for both, and I need to have canaries, blue-green for both. Oh man, it's going to become, okay. So we have decided from a TCO perspective, stick to Kubernetes, right? This is the kind of reasoning that you need to do as a solution architect. Make sense? Oh, please make a session with Kinesis Data Analytics. Good, good. Let me show you something here. So see, this was, we just have 7 people. So this was our game today, right? So I have this on. Let me do 3 hours here just to check. And what is your environment? 1 hour, 1 hour. What I did here? Custom. Local time zone. Let me reload this and check what's happening here. Probably I lost the connection. So cool, it's back. So this is we are having our fun time today. So let me enter full screen, right? Number of API requests, Kinesis consumption, see, super, I'm not using auto-scaling here. See that we have a lot of capacity, unused capacity here. So this is like not using well DynamoDB, right? See latency here, dropping from this to this. Why? Because here we have the Lambda, the cold start for Lambda. It's something that we need to take care of as well. And there's a lot of ways of solving that. Right? For example, with code,
the throughput on that.
Yes, you can have some lambdas warmed and keeping running as a container as well there, right? So there's a lot of way of solving that. So this, for example, something that you can do. You don't need something special. You can use CloudWatch to monitor your infrastructure if you want. Right. So the workshop, the Alien Attack workshop, is a full day of discussion. We can do, of course, something that with Kinesis Analytics. There's a lot of space of doing something here with Kinesis Analytics, even testing at scale. So if you want that, we can organize with Continue to do something with that.
Well, this was an awesome presentation, and I liked the keeping everyone engaged with the polls definitely going to be stealing that for my virtual talks. But yeah.
Tyler,
Nobody
Tyler, please, first one here, send an email or to me or to
I can drop your email in
yeah,
here. But yeah,
yeah.
Tyler,
So
if you send me or Fabian your address, he'll get you the Alien Attack T-shirt.
yes,
Thank you. Just send me an email or emails to send it to.
cool. Sorry to interrupt you.
No, you're
James.
fine. Wanted to make sure that he got that because that's a pretty good score. All
All
right, guys. If there's no more questions, thank you for coming. I already saw one suggestion for the Kinesis data analytics. If you want to talk, we're trying to do these monthly. We'll see how it goes. And if not, we'll try to keep it to bi-monthly as we can keep up with speakers and all of the other meetups that I help run. If you're interested in helping run or speak, just let me know. I'm on Meetup. And tomorrow, like I said, CJ is speaking at the CNCF Meetup, which is also just search for Cloud Native Louisville. Again, thank you everyone for coming. Fabian, thank you for hosting, and I will make sure to send you a bottle of bourbon like I do for all of my other speakers. Thanks, guys. Bye.
Thank you.
Fabian, if you're trying to tell me something, you're on mute.
Sorry. You have everyone